All right, our topic today, one variable inequalities. This is going to seem amazing to you. You already know a whole branch of math that you didn't even realize you knew. Watch this. How would I solve this problem? X plus 5 equals 10. Yeah.
Subtract 5 from both sides.
Good. That leaves us with x equals 5. Now, where is that on a number line? If I were to draw a number line, here's 0, 1, 2, 3, 4, -1. Where is this on this number line? Yeah.
X is the last number.
Right here, right?
Yeah.
The last number on the right. So I could make a dot there, or I could even make a dot up here to kind of show where that is on this number line. And I've never asked you to do that before. But you've seen a number line, you know where things are. With inequalities, I will be asking you to include a number line with your answer. Okay? Now watch this. X plus 5, so far it looks the same, right? Is greater than 10. Does that change anything? What did I change from this to this?
Greater than to an equal.
Yeah, instead of equals, we now have greater than. Well, okay, well, if x plus 5 is greater than 10, what's x greater than?
10. No, x is greater than 5.
Yeah, we can still solve it in the same way. I can still subtract 5 from both sides, and x is now greater than 5. That's it. Okay. It's the exact same process as solving an equality so far. Now there will be one thing that's drastically different, sort of. And now how do I put this on my number line? So here's 0. 1, 2, 3, 4, 5. Now this is the real trick. This is the one thing that you have to remember. Okay, this is kind of the new learning for today. We look at this symbol here. The symbol is greater than. If the symbol is either greater than or less than, we use a hollow dot. Okay? So I'm going to put a hollow dot at 5 because x can't actually be 5. 5 plus 5 is not greater than 10. It's not true. But anything slightly larger than 5 would make that true. So if x were 4, 4 plus 5, that's not greater than 10. So x can't be any numbers over here. But if x were 6, then we'd have 6 plus 5 is greater than 10. That is true. That's a possible answer. If x were 7, if x were 8, 9, 10, 11, 11 plus 5 is greater than 10, right? So all of these answers over here make this statement true. In order to show that, I'm going to draw an arrow in that direction. Because I listed some of the possibilities. 6, 7, 8, 9, 10, 11. But there are others, right? X could be 5.00002. And 5.00002 plus 5 is still greater than 10. We could list an infinite number of possible values for x. Any number of decimals in here, right? 5.793215627654321, right? Plus 5 is greater than 10. Any number greater than 5 is a possible solution for x. And we show that with this line with an arrow on the end. What we're saying is all of these numbers over here make this statement true. Okay? So I just made that sound way more complicated than it really is. I'm trying to give you kind of the reasoning behind it. So let's do another example. So if I have x minus 3 is less than 4, how would you solve that? Pretend it's an equal sign. How would you solve it if it were an equal sign?
Plus 3 on both sides.
Add 3 to both sides. Perfect. Now we have x is less than 4 plus 3, which is 7. And that's it. I'm done. I have x all alone on one side. That's all there is to this. Okay, and now I'm going to do my number line. So I'm going to find, I'm pretty much always going to start with 0. Unless I'm really far away from 0. 1, 2, 3, 4, 5, 6, 7. Okay, I don't want to ever see a number line that just looks like this. Just has one number on it. I want you to show me some other numbers. So where is 7 relative to 0? Well, it's to the right from the number line. Okay, I have a less than symbol, so I'm going to use a hollow dot. And I know x is less than 7. Which direction should I make my arrow go? That way, right? Because x would be anything that's less than 7. I want you to notice something about these arrows. Here's the less than symbol, right? It goes like this. Look at the end of my arrow. It kind of looks like the less than symbol, doesn't it? If I were to erase this, hey, it's a less than symbol. So that's going to kind of help you remember which way to draw your arrow, as long as you write x first. Okay, if you have 7 is greater than x, this is technically the same thing, but then this is not going to help you draw your arrow anymore. So as long as you write x first, x is less than 7, that will show you which direction to draw your arrow in. Okay. All right, let's do another one. 5x is greater than 30. How would you solve that? 5x is greater than 30. How would you solve it if it were an equality?
Divide both sides by 5.
Exactly. I'm going to divide both sides by 5. 5x divided by 5 is just x. Greater than 30 divided by 5 is 6. Cool. Make a number line. 0, 1, 2, 3, 4, 5, 6. Hollow dot. Greater than 6. So my arrow goes that way. And that's all there is to it. All right. What if I have something slightly different? X over 3 is greater than or equal to 2. I'm trying to get x alone on one side. So how do I get x alone in this case? What's opposite of x divided by 3?
X times 3.
Yeah, times 3. So I'm going to multiply both sides times 3. Boom. X is greater than or equal to 2 times 3, which is 6. Now the key here, I no longer have greater than or less than. So when we have greater than or equal to or less than or equal to, now I use a solid dot. Because I have this equal to symbol here, that means that x could actually be 6. So when I draw my dot here, I'm saying, yeah, It's everything including 6. Filling in the dot is like saying including this number. And the reason we do that is because it says equal to 6. X is greater than or equal to 6. Solid dot. Then my arrow is going to be everything bigger than 6. So I draw an arrow going in that direction. Okay? That's it. Let's do another one like that. Let's do one that's more than one step. 2x minus 4 is less than or equal to negative 2. Alright, what would be the first step in solving this problem?
Adding 4 to both sides.
Adding 4 to both sides. Those are going to cancel out. So now we have 2x is less than or equal to negative 2 plus 4 is positive 2. And there's one more step to solve that. Is divided by 2. 2x divided by 2 is x, less than or equal to 2 divided by 2 is 1. Number line 0, 1. Am I going to use a hollow dot or a solid dot? Solid. How come?
Because it has a equal to.
Has the equal to. So that means a solid dot. Which direction do I make my arrow go in? To the left or to the right?
The right.
In this case, we have less than, which goes to the left.
Yeah.
Less than to the left.
I was getting to less than.
Yeah, it's easy to get confused on this part. So if you're not sure, just look at your number line and go, okay, this number here is 0. Is 0 less than or equal to 1? Yeah. So I want my arrow to go in that direction. This number over here is 2. Is 2 less than or equal to 1? No. So I don't want my arrow to go over towards 2. So you can kind of check to see if the points work. And that will help you figure out which direction to draw your arrow. All right. There's one more rule to this. One more rule. Negative x is greater than or equal to 3. How do I solve for x here?
You have to make the 3 negative.
Yeah. I have to divide both sides by negative 1. Right? Negative x divided by negative 1 is just x. Divided by negative 1 is negative 3. I could also say that I'm multiplying by negative 1. It's actually the same exact thing. Right? I could consider this to be multiplying by negative 1. Now here's the last rule. If you divide or multiply an inequality by any negative number, switch your inequality. So I'm going to switch greater than to less than. I'm going to switch less than to greater than. So here, did I divide or multiply by a negative number? In this problem?
Yes.
Yeah, divided by negative 1. So I'm going to switch the greater than or equal to less than or equal to. You guys see what happened? It looked like that. I divided by a negative number, so I switched it to that. Okay? So now I'm ready to graph it. Solid dot or hollow dot?
Solid dot.
Solid dot because we have the equal to. Left or right?
Right.
It says less than -3. So if I go to the right, my arrow is going to look like a greater than symbol, right? Which is -1 less than -3? Would that be true?
No.
No. -1 is bigger than -3, right? So did I draw my arrow in the correct direction?
No.
No, I didn't. Which direction should I draw my arrow?
The left.
The left. And look, the end of the arrow looks like that less than symbol. It's going to help us remember what to do. Now let's do an example like that. One more example like that. -2x plus 1 is less than 7. First step. Subtract 1 from both sides. -2x is less than 7 minus 1 is 6. Okay? Divide both sides by -2. Whoa! What did I just say? Divide by -2. Whenever you hear yourself saying divide by negative, you have to just stop in your head, in your brain. You go, whoa, I'm dividing by a negative. Or if you're multiplying by a negative, I'm multiplying by a negative. Why do we have to make such a big deal out of this? What am I going to change? The -2's cancel out. We have an x. 6 divided by -2 is a -3. What happens in the middle? When I divide by a negative number, I switch the direction of my inequality. So instead of less than, x is actually greater than -3. Okay? 0, -1, -2, -3. Solid dot or hollow dot? Hollow dot. To the left or to the right? To the right. Greater than means to the right. If x is greater than -3, x could be -2, -1, 0, 1, 2, 3, 4, 5, 7.96254321. Right? All of those would be greater than -3. So our arrow has to go in this direction. All right, do you guys have questions? Questions about that? No?